Hi, grade 9. So for this lesson, we're going to be looking at carrying capacity and limiting factors that will affect how many organisms can live in an ecosystem. So you should have your notebook in front of you so you can write everything down and the handout for today's lesson as well. So we'll start with the science starter. So from previous lessons, describe a mutualism relationship and then also describe a commensalism relationship. So you can pause the video here and take a couple minutes to do that. Okay, so mutualism, you know that both benefit, and with commensalism, one benefits, and then the other is kind of like neutral. It's not benefited, but it also isn't harmed. Okay, so the definition of carrying capacity, which is something important for ecosystems, is basically the largest population of a species that an environment can support. Okay, so that's just the maximum number of species that can be supported and the maximum number of organisms. So supported meaning, resources and food and things like that. Okay, so I've already mentioned a couple, but again, just wanted you to think what factors might affect carrying capacity. Okay, here just a few to get written down. So materials and energy, so how much energy and resources there are to move around. Food chain, so how big or small the food chain is. Competition, and also density, so how many organisms are in a certain amount of space. Okay, and we'll go into detail on all of those additional factors. Okay, so materials and energy. So all populations of organisms are limited by the amount of usable energy from the sun, and also the supply of water, carbon, and other nutrients. Okay, so an example would be like a rainforest, which would have lots of water, or tundra, which might have very little. Okay, so they're going to differ in their materials and their energy. Okay, then food chains. So the population sizes at any trophic level are limited by population sizes in all the levels below it. Okay, so we've talked about this before with interdependence. So a predator can only be or the populations of predators can only be so large depending on how much prey they have to consume. Okay, so populations are limited by their food supply. Okay, and then competition, we have intraspecific, which is among members of the same species because each of those organisms have similar needs. So that could be over resources, habitat, space, and mates. And then interspecific would be between different species in the same area. Okay, and the last one, density. So different species have different requirements depending on their size, environment, and way of life. So overcrowding can lead to disease, stress, etc. Okay, so if there's lots of organisms in an area, and the higher density is more affected by factors like forest fires, drought, etc., because lots of animals would be affected by that. Okay, so with each of those 4 factors in mind, I want you to decide if they represent biotic or abiotic factors. So materials and energy. So that would be abiotic, because that's not living. Second one, food chains. That would be biotic because it is living. Competition, both within and between species. Good, that would be biotic as well because it's living. And then density. So that would be, again, biotic, the amount of organisms in a particular space. Okay, so a couple practice questions. Describe how energy availability affects carrying capacity, and also 2 members of a moose population are trying to find food. I want you to tell me what type of competition that is. Okay, so pause the video here and take a couple minutes to answer those 2 questions. Okay, so the answer for the first one, all populations of organisms are limited by the amount of usable energy from the sun, supply of water, carbon, and other nutrients, and that would be intraspecific between 2 members of the same species. Okay, so next thing I want you to think about, this is unrelated to science, but it's all to do with the same idea. So I'm trying to bake a cake, not create, I should say bake. I have the following ingredients. So I have flour, eggs, sugar, and vanilla. Okay, I run out of eggs first. want you to think, will I be able to produce any more cakes? And using that idea, I want you to try to create a definition for the term limiting factor. Okay, so once I run out of something, I'm not really going to be able to make any more. And we can relate that to this idea here and ecosystems. So a limiting factor, when a process depends on two or more factors, the rate of that process is limited by the factor which is in shortest supply. So essentially, first thing you run out of, that process can't go on anymore. So an example, again, this isn't a biological example, but just another example for you. So the rate of car building is limited by the factor which is in short supply. So a factory is making car parts every week. It can make 10 engines, 55 seats, 60 doors, and 100 windscreens. So first thing I want you to think about, what would be the limiting factor in this example? So thinking we need one windscreen per car, we need 4 doors per car, 4 seats per car, and 1 engine per car. So what would be the limiting factor? Okay, so the engines in this example would be, and because we only have 10 engines per week, we can only make 10 cars. So we would run out of engines first. Okay, so another example here, baking a cake again using the same ingredients, so flour, sugar, eggs, and vanilla. This time I have plenty of eggs, but run out of sugar first. So what is my new limiting factor? Okay, so in this example would be the sugar. So the practice question here, a student is making lemonade to sell at home. They're using lemons, sugar, and water to make their lemonade. So each batch requires 6 lemons, 3 cups of water, and half a cup of sugar. They have 9 lemons, 15 cups of water, and 1 cup of sugar, which is the limiting factor, and justify your answer. So 1 mark for getting the correct factor, and then 2 marks for your justification. So you can pause the video and take a couple minutes to answer that. Okay, so the correct answer would be lemons. That's the factor in the shortest supply. They can only make 1 batch with 6, and they wouldn't have enough for the second batch. Okay, so now we're going to relate the idea of limiting factors to ecosystems. So ecosystem limiting factor is anything that affects the population size or slows slash stops it from growing. Okay, so examples, you could have biotic limiting factors like food, mates, and competition, or you could have abiotic limiting factors like space, temperature, and amount of sunlight. Okay, so there's an example here. If there are not enough prey animals in a forest to feed a large population of predators, then food is the limiting factor in this example. Okay, so thinking about it, if you're at home, so what is the limiting factor in the following example? A small pond is home to a large population of fish. Okay, so this would be like competition, would be affecting that ecosystem, access to food and things like that. Okay, so limiting factors and carrying capacity, basically the limiting factors determine the habitat's carrying capacity. So the thing that runs out first that affects the growth of the population, that's going to affect how many organisms that ecosystem can support. Okay, so that's the end of this lesson, so make sure you have all the notes written down that you need.